Let's begin our journey into trig for this year. So trig ratios, very quick recap on the very basics, which we certainly should know by heart by now. That is a right angled triangle. The largest side in a right angled triangle, of course, we call the hypotenuse, which comes from Egyptian, I think, or it might be Greek. It's one of the two. There's something about stretching, hypotenuse. Anyway. We mark one of the angles in. Once we've noted an angle, the one next to it, of course, we call adjacent, and the one across opposites. And so we get our abbreviations. So they are not sin, cos, and tan, of course. They're sine, cosine, and tangent. And then we also have what we call the reciprocal ratios, which basically, as the name suggests, are our main three ratios turned upside down. So we have secant, cosecant, and cotangent. Now, co stands for complementary. So whenever you have complementary ratios, you know that the angles will add up to 90, just like complementary. So if we're saying the sine of what's the same as cosine of 25, well, we know they've got to add up to be 90, and so we get 65. The cotan of x minus 20 being the tan of x plus 30, then again, I know the two of them should add up to be 90, so we'll get x is 40. So co means the complementary ratio. All right, the first standard sort of questions. First of all, when we had to find a side, we had to set the ratio up and work out which ratio. In this case, opposite over adjacent is, of course, tan. We can get ones where the pronumeral ends up on top. So, of course, to solve that, we just multiply by the 13 and come up with our approximations. Then there are other ones that when we set it up, the pronumeral ends up on the bottom of the fraction. And, of course, we tend to stick with the main three because they're the buttons we have on the calculator. So I could have, yes, turned this into a cosecant ratio and had x on top, but I don't have a cosecant button on my calculator, so a bit of a waste of time. But that's easy enough. If x is on the bottom of the fraction, then I divide by the trig. So pronumeral on the top, we multiply by the trig. Pronumeral on the bottom, we divide by the trig. So 5 over sine 32, and there's our approximation. Third type, of course, is then if we have to find an angle. Again, we just set up our ratio, and we use inverse trig, which is a topic we'll look at in far more detail next year when we look at inverse functions in more detail. But whether or not you've noticed this or not, on your cosine button, written above it in little letters or something, will be cosine with a -1 there, which stands for inverse cos. And of course, that's the button we use when we want to find the angle rather than the ratio. So 44 degrees, 25 minutes is the answer I've got. Okay. There are some exact ratios that turn up all the time. We see them very often in questions, and so it's important we know them. I guess the most basic way, if you ever get them, is to remember how the exact ratios were created. So what I've got here is an isosceles triangle where the sides are 2, so therefore all the angles are 60. Well, if I chop it in half, I get my 30-60 triangle, and so the sides become 1, 2, bit of Pythagoras, we get the other sides √3. So from that we can read off our exact ratios for both 60 and 30. So sine 30, 1 on √2, cos 30, √3 on 2, tan 30, 1 on √3, sine 60, oh look, sine 60, same as cosine 30, 60 and 30, complementary. Cosine 60 is half, oh look, cosine 60, same as sine 30, 60 and 30, complementary. And tan 60 is √3. The 45 one, we have our right-angled isosceles triangle. We'll make the sides equal to 1, gives us a hypotenuse of √2, and now we can read off that one. Sine 45, 1 on √2, cos 45, 1 on √2. Oh look, sine 45, same as cos 45, complementary. Now, there is an alternative way of remembering our trig ratios. I'll put a little table like this. Don't know whether you've ever noticed this, but if I write them in a different way, there's a lovely pattern. Sine of 0 is √0 on 2. Sine of 30 is √1 on 2. sine 45 root 2 on 2, sine 60 root 3 on 2, and sine 90 root 4 on 2. So you get this lovely pattern. Cosine then reads the other way, and tan is sine divided by cos. So I end up with those ones. So that's a kind of a neat way of doing it, just using the patterns of the numbers. Okay, measuring angles. Angles of elevation. As the name suggests, it's when we elevate or lift the angle, or our eyes if we're looking at something. And so this expression here would be the angle of elevation of B from A. So the angle is always where it's from, where you're measuring it from. So of something from somewhere. Angle of depression, that's then when we lower it. And this one would be the angle of depression, again, of X from Y. So it's an angle of depression of something from somewhere, where we're measuring it from. And of course the neat thing is, the angle of elevation will always equal the angle of depression, because if you put the two pictures together, you end up with alternate angles. Compass bearings. So we have our north, south, east, west, which of course is where the word news comes from. Information from all around the globe, NEWS. Okay. Now, obviously not all measurements are exactly on those, so we divide them in half, and we use the north-south being the primary ones, so we mention those first. So north-east, not east-north, and so on. But we can repeat that pattern, and the way we would name them, again, we start from the primary, so this will be halfway between north and north-east is north-northeast. The east measurement in the next one is more important, I suppose, for want of a better word, than our red one. So we say the east first, east, northeast, and so on. And I could keep going like that. Halfway between east, southeast, and southeast. Well, southeast would be the more important of these. You think of levels, it's higher up in the scale. So you would say southeast, east, southeast. Gets a bit clumsy after a while. So we tend to stop doing that and simply saying, okay, how many degrees? So we'll start at north and go, how many degrees towards the east? And things like that. Now, a true bearing just simply always starts at north and then goes clockwise however many degrees. So here's X and Y. If I know there's north, I put my compass on there. I know that angle in there is 30. So the bearing of Y from X, again, it's of something from where you're measuring it, where the angle is. It's as a true bearing, it's 120. Start at north, rotate 120. As a compass bearing, it would be south 60 degrees east. If I was looking at it the other way, if I was actually at Y, then it would become a true bearing of 300 degrees and a compass bearing of north 60 degrees west. Diagrams are so important with these sort of pictures. Maybe not the simple ones, but certainly the more involved ones. 1 to 3, where I've just said pick some, they're just basic calculator questions. Do you know how to use your calculator? I mean, up to you how many you want to have a go at there.